Hey everyone, let's look at number 10 in section 6.3. We're going to find the volume of the solid obtained by rotating the region A in the figure that I've reproduced from the problem here about x equal -3. And they've got sort of a generic picture they've been using for several of these questions in this portion of the Achieve homework. But they have this parabola, they're calling y equals x squared plus b, and then they're looking at region A as being from the y-axis or x equals 0 to x equal a, where in this problem b is to be equal to 8, a is equal to 4. Again, your problem, these numbers might vary, and where we're rotating about might vary, but it's probably going to be the same thing, x equals some negative number. Um, Okay, so I redrew everything. If our function y will be now x squared plus 8, right? Since b is 8, and that means we're going to be starting at when x is 0, y is 8, and then when x is 4 here, because a is 4, when x is 4, y is equal to 24. That's the height here. So this is the region here. They also have region they call B down here, shaded differently, but this is the region we're talking about. And we're going to take this and rotate it about the vertical line, right? X equal -3 is a vertical line, not a horizontal line. So we're going to do that. In order to do the disk or washer method, we're going to have to integrate with respect to y. So I do need to realize I'm integrating from 8 to 24. And basically, I pick an arbitrary value of y here, and I look at this this rectangle here, which is horizontal, rotate that about x equal -3, and hopefully you see we're going to get a washer. We're going to get a washer down here. It's rotating about the line x equal -3. This is my inner radius of the radius of the hole I call little r. Big R is the radius of the bigger circle. And so the shaded in region that I'm looking at, which is the area of that one cross section, will be the area of the big circle minus the area of the little circle, or factoring out the pi, big R squared minus little r squared. Now, what's let's see what little r is. Little r will be from the axis of rotation, which is x equal -3, basically to the left end of our rectangle, right? As this rotates around and goes around, that's the hole right there. That's generating that hole. So little r is just the distance from this axis of rotation to the left side of our rectangle. I said bottom. I guess if you looked at it 90 degrees, now it's the bottom. It's like rotating this way, right? Um, and so notice that's always the bottom of the rectangle. It's the bottom. The left side of the rectangle is always on the y-axis, which is again that y-axis is x equals 0, right? And then the other end is on x equal -3. So the distance is 3 units. Little r is equal to 3. All right. Please don't say it's -3. That makes no sense, right? The value of r has to be a positive quantity, right? It's the distance from 0 to -3, which is +3, right? So r is little r is +3. And then what about big R? What about our outer radius? Well, that's going to come from the axis of rotation all the way to here, right? The right end of our rectangle. Okay, so that's that distance right there. So what is that? Well, of course, I'm looking at the x length, right? And you know what that is. This end is again on x equal -3. What's this end on? Well, it's on this curve, which has the relationship y is equal to x squared plus b. Of course, b is 8. Y equals x squared plus 8, right? So if that's the case, what is the value of x? What is that? This basically the length of the rectangle. What is that? Well, I just solve for x, right? I can subtract 8 from both sides, and then solving for x, I take the square root. I'm only going to look at the positive root because we're obviously looking in the first quadrant, so x and y are both positive. So that's the value of x. And check that out. That's true. That's the length of this rectangle as y varies from 8 to 24. At 8, the rectangle has a length of 0, right? And then it gets bigger and bigger and bigger. So by the time y is 24, it should have a length of 4, right? A is 4. And you can see that if you plug in 8 into my formula, I do get 0. And if you plug in 24, 24 minus 8 is 16, and the square root of 16 is 4. So that's generating the correct length we want. So it's this length basically plus the 3, right? Or I can think of the x value, which is the square root of y minus 8, minus x equal negative 3, right, which is the left end. So going all the way from the curve here, this parabola, all the way to this line here. So this is the curve here is the line or the curve x equal the square root of 1 minus 8, and this curve is x equal negative 3. So a couple ways to think about it. So if I subtract, right, a negative 3, I get plus 3 again. Or you can just think of this square root of y minus 8 is the width, if you will, or the x length of our rectangle, and then of course 3 is the distance from the axis of rotation to the y-axis. So the total length, the total value of big R, our radius, is equal to that. Okay, so with that, I do want to compute little r squared. That's easy. Little r is 3, so I get 9 for r squared. Big R squared, though, is this stuff squared. So FOIL that out. First times first gives me y minus 8. The outer inner is 3 times the square root of y minus 8. And so adding those two together gives me 6 times the square root of y minus 8. And then last, 3 times 3 gives me 9. So make sure you understand how we get this by foiling out this expression here. And then I'm going to be taking big R squared, factor that pi out, and I'm going to be integrating this cross-sectional area. And notice I'm integrating from 8 to 24 because we're integrating with respect to y now, right? We're integrating as y varies from 8 to 24. All these cross sections that are washers as we form this solid from this rotating this region A about the line x equal negative 3. And so it's going to be from 8 to 24, pull the pi out, big R squared minus little r squared. And here's big R squared, right? This plus 9 minus little r squared, which is 9, and 9 minus 9 is gone. So it's just this part, right? That's what I'm integrating from 8 to 24. So finding the antiderivative, of course, the antiderivative of y is 1/2 y squared. Antiderivative of 8 is 8y. What's the antiderivative of this? Well, of course, y minus 8 is y minus 8 to the 1/2. By a simple u substitution, u is y minus 8, du is dy. So this integral for this part right here would be 6 u to the 1/2, right? Square root of u is u to the 1/2. So the antiderivative is by the power rule. Add 1 to a half gives me 3/2. Dividing by 3/2 is the same as multiplying by 2/3. 6 times 2/3, 3 goes into 6 twice. 2 times 2 is 4. So I get that. And then replacing u with y minus 8 gives me this. So the antiderivative of 6 times the square root of y minus 8 is this. Okay. And then I'm going to plug in 24 for each of these values. 24 minus 8 is 16. And then minus the evaluation of 8. 8 squared is 64, divided by 2 is 32. 8 times 8 is 64. Notice if I plug in 8 here, I'll get 0. And there it is. I mean, you can simplify this with your calculator if you want to. Of course, 16 to the 3/2 power, that's what? Square root of 16, which is 4. And then cube it, which would be 64. Do the rest of the calculation. You get 384, don't forget your pi, times pi. Okay, hope this is helpful.